Welcome to our Unity tutorial series. Today, we'll dive into the fascinating world of game development as we explore the creation of a state machine. By leveraging the power of C#, we'll build a solid foundation for our RPG game. Let's get started on this exciting journey. Before we begin, make sure you have Unity installed on your computer. Create a new Unity project or open an existing one where you want to implement the state machine. Once you have your project ready, let's start by creating a new script. In your script folder, create a new C# script and name it state. Open the script and let's start writing the code. In order to create a robust state machine in Unity, we need to start by defining a base class for our individual states. This base class will serve as a blueprint that outlines the required structure and behavior for each state. In object-oriented programming, we can accomplish this by creating an abstract class. An abstract class is a class that cannot be initiated directly but can be used as a foundation for derived classes. It provides a common interface and defines certain methods or properties that must be implemented by its derived classes. In our case, the state class will be an abstract class acting as a blueprint for all the specific states we create later. Let's take a closer look at the code. Here, we define the state class as an abstract class by using the abstract keyword in the class declaration. Inside the class, we declare three abstract methods: enter, update logic, and exit. These methods represent the fundamental behavior associated with a state. The enter method is called when a state is entered, allowing you to set up any initial conditions or perform any necessary action specific to the state. For example, playing the animation for that specific state. The update logic method is called repeatedly during the state's lifespan and allows you to update the state's logic or perform any ongoing actions. Finally, the exit method is called when transitioning out of the state, giving you the opportunity to clean up any resources or perform any necessary actions before switching to a new state. By making these methods abstract, we enforce that any class derived from the state-based class must implement these methods. This ensures that each state adheres to the required structure and behavior, providing consistency in our state machine implementation. Now that we have our abstract base class defined, we can proceed to implement the state machine class, which will utilize these states to manage behaviors in our Unity project. In your script folder, create another C# script and name it state machine. Open the script and let's start writing the code. The state machine class will control the switching between different states and ensure that the appropriate behavior are executed for each state. Let's go through the code line by line and understand what each part does. Inside the state machine class, we declare a private member variable called current state of type state. This variable will keep track of the current active state. Next, we define a public method called change state, which takes a state object as its parameter. This method is responsible for transitioning between states. So inside the change state method, we first check if there is a current state active. If there is, we call the exit method of the current state, indicating that this is being exited. We then assign the new state provided as the parameter to the current state variable. Finally, we call the enter method of the new state, indicating that this is being entered. In the update method, we check if there is a current state active. If there is, we call the update logic method of the current state, passing in the delta time. With this state machine class, we can easily switch between different states by calling the change state method and providing the desired state as an argument. The enter and exit methods of the states will be called accordingly, ensuring smooth transition and executing of state-specific behaviors. In the next step, we will explore how to use this state machine in our Unity project. So let's move on. Now that we have our state machine implemented, let's see how we can use it in our Unity project. Create a capsule object in your scene by adding a capsule primitive game object. Next, attach the state machine script to the capsule object. This will enable us to manage and control different states for the capsule. You can also attach the state machine script to any other game object that requires state-based behavior. Congratulations! You have successfully learned the foundation of creating a state machine in Unity using C#. This state machine provides a solid structure for managing different behaviors and states of your game objects. By organizing your code into separate states, you can create more modular and maintainable game logic. In the next video, we will take this knowledge further and implement a player state machine along with an idle state. We will explore how to handle player-specific states and transitions to create a dynamic player behavior. Stay tuned for the next tutorial where we dive deeper into the implementation details. Thank you for watching this tutorial. If you have any questions or suggestions, please leave them in the comment below. Don't forget to like and subscribe to our channel for more Unity tutorials. Happy coding!